Good morning to all of you. In previous sessions, we have seen the realization structures for IR systems, where we discussed direct form 1 realization, direct form 2 realization, and cascade realization. Today, we will be discussing one more realization structure for IR system, that is nothing but the parallel form realization. Okay. So, as you can see here, one example has been given where we have to determine the parallel realization of the IR digital filter, or you can call it as digital system or discrete time system, characterized by the transfer function. So there are two different systems, right? So initially we'll try to obtain it for the first system. Okay, so we'll solve the first example initially here. Okay, so the given transfer function is, so what has been given, h of z is equals to 3 in bracket 2z square plus 5z plus 4 whole upon 2z plus 1 in first bracket, in second bracket z plus 2, right? So as we know that for parallel realization these terms should be in addition, right? As you have seen in the previous session, in cascade form realization we have used the terms in multiplication. So if you want to identify the cascade form realization of these equations, so you can use this equation as it is. Simply you have to represent these h of z with negative powers of z, and you can represent these terms in the multiplication. Okay, so you can obtain directly the cascade form realization from these equations, right, or the given transfer functions. But to obtain parallel realization we need these terms in addition form. So we have seen in case of inverse z transform, there we have seen one method, that is partial fraction expansion method. So by using partial fraction expansion method we identified the inverse z transform. So here we'll be using that partial fraction expansion for representing this transfer function in addition form. Okay, but for that purpose we need to make certain adjustment here again. Okay, so here the term should be z only in denominator, as we have seen in case of inverse z transform while applying the partial fraction expansion, right? So to represent these terms, so what I will do, I will multiply before applying the partial fraction expansion. I will multiply 1 by z on both sides, and I will adjust these terms here, right? So that here I will take 2 common from the denominator. Okay, and again 1 by z, 1 by z I will be multiplying on both sides, right? So by multiplying 1 by z on both sides, right? So what you will get here, so here you will get h of z upon z, right? H of z upon z is equals to, so here this from the denominator I will be taking 2 common, right? And also I will be multiplying it with 1 by z, right? So if I'm taking 2 common, so I can represent it as 3 by 2 in numerator, because these are constant terms, right? Remaining bracket I will keep adding it, 2z square plus 5z plus 4 whole upon, I am multiplying 1 by z on both sides, so h of z upon z I have written, and this 1 by z is there, right? So these two I have taken common from this bracket, so in bracket what will remain, so it will be z plus 1 by 2 will be there, and the remaining bracket will be as it is, z plus 2, right? So for applying partial fraction expansion, so I can represent these terms as a upon z plus b upon z plus 1 by 2, right, plus c upon z plus 2. Okay, so this is how you can represent these terms for identifying the values of constant ABC, so that after substituting these values of ABC, you will get these terms in addition form for parallel form realization, right? So let's write this equation here. So this what 3 by 2 in bracket 2z square plus 5z plus 4. So if I'm sending this denominator on right hand side, so what I will get, so I will get this 3 by 2 in bracket, what is this, so 3 by 2, what is that in bracket, 2z square plus 5z plus 4 is there, right? If I'm sending this denominator there, so z will get cancelled, right? So a in bracket, what will there, z plus 1 by 2, right? Then z plus 2 plus b multiplied by this z, this z plus 1 by 2, z plus 1 by 2 will get cancelled, and z plus 2, right? So z in bracket z plus 2 will be there, plus similarly c again multiplied by this term will be this z plus 2, z plus 2 will get cancelled, z in bracket z plus 1 by 2 will be there, okay? Z in bracket z plus 1 by 2 will be there, right? So to get the values of ABC, you have to substitute the values of z, okay? So what you will do, you will solve these equations, this above equation, for different values of z, okay? For finding value of a, put z is equals to 0 in above equation, okay? So if you are substituting z is equals to 0, so these two terms will get eliminated, that is v multiplied by 0, c multiplied by 0. So these two terms will be 0, right? And here you will get a in bracket 1 by 2, 0 plus 1 by 2 will be 1 by 2, and here you will get again 0 plus 2 will be 2. So again this 2 will get cancelled, so here you will get only a. So a is equals to, then again 3 by 2 in bracket, this will be 2, it will be 0, right? So this will be 0, this will be 0, and then 4 will be there, right? Then 2 to the 4 will be there, and 3 to the 6 will be there. So that means you will get value of a is equals to 6, right? If you put the value of z is equals to 0 in this equation, right? Similarly for b, put z is equals to, what you will substitute, z is equals to minus 1 by 2 in the above equation, right? So if you are substituting z is equals to minus 1 by 2, so this term will be 0, right? As well as this term will be 0, only this term will remain, right? So what you have here, so 2 minus 1 by 2 will be there, right? And multiplied by minus 1 by 2 will be there, correct? Similarly here you will get this 2 multiplied by 1 by 4 minus 5 by 2 plus 4, and 3 by 2 will be there, right? So if you solve it for the value of z is equals to minus 1 by 2, then you will get value of b, and what you will get, value of b is equals to minus 4 you will get there, right? I'm substituting different values of the value of z here, z is equals to minus 1 by 2 if I'm substituting. So this term will be 0, this term will be 0, this will be b multiplied by minus 1 by 2 in bracket minus 1 by 2 plus 2, right? Correct. So similarly here it will be 3 by 2 in bracket 2 by 4 will be there, plus minus 5 by 2 will be there, plus 4 will be there. So if you simplify it, you will get b is equals to minus 4. And for c, you have to put what, z is equals to minus 2 in our equation. So if you are substituting z is equals to minus 2, so these two terms will be 0, right? So these two terms will be 0. Then here you will get minus 2 in bracket minus 2 plus 1 by 2. Again here you will get 8 plus it will be minus 10 plus 4 multiplied by 3 by 2, right? So if you simplify it, so you will get the value of c, right? And you will get value of c is equals to 1 after simplification. Okay, so these three values you will get when you put value of z is equals to 0, z is equals to minus 1 by 2, and z is equals to minus 2. You will get values of a, b, and c respectively, right? So now you can substitute these values in this equation. Okay, so what you can write here, you can write this h of z upon z is equals to, so the value of a is 6, so it will be 6 by z, right? You will get 6 by z as a first term, right? Second term, the value of b is 4, right? Not 4, I think minus 4. Okay, so it will be minus 4 upon z plus 1 by 2, so minus 4 upon z plus 1 by 2 will be there, right? And the value of c is 1, so you will get here 1 upon z plus 2. Okay, now you can send this z on the right hand side, so you will get h of z, so this z will get cancelled, so it will be 6 minus 4z upon z plus 1 by 2 plus z upon z plus 2. Okay, now I can send this z in denominator, so it will get this denominator will get multiplied with z inverse, so final h of z will be 6 minus 4 upon 1 minus 1 by 2, not minus, plus 1 by 2 z inverse will be there, plus 1 upon 1 plus 2 z inverse will be there, right? So I have sent this z in denominator. Now you can directly realize this system function in parallel form, okay, because these terms are in addition form now, right? So I'll just draw that realization structure on next slide, right? So the parallel form realization of given digital filter is shown in following figure. Okay, so before drawing this structure, I'll just rewrite this equation. What is that? H of z is equals to 6 minus 4 upon 1 plus 1 by 2 z inverse plus 1 upon 1 plus 2 z inverse. Okay, now how to draw it? So again, in input you can indicate x of n or x of z, right? So as there are three terms, so there will be three parallel lines, okay, in this structure. So first will be for this constant 6, right? So I'll be using constant multiplier there, correct? So this will be added here with adder output. I can indicate it as y of n or capital Y of z. Next, the term is minus 4 multiplied by this 1 upon 1 plus 1 by 2 z inverse. So for minus 4, I will be again using the constant multiplier, right? So minus 4 will be there. This 1 upon 1 plus 1 by 2 z inverse, I can draw it by using feedback, right? So here I'll be using 1 z inverse, right? So which will be fed back into the system. Here plus 1 by 2 is there, so therefore I will be multiplying it with minus. Okay, in denominator terms the coefficient sign should be changed. Okay, so this will be added here, right? And this complete term will be added in this adder, right? So this is nothing but minus 4 upon 1 plus 1 by 2 z inverse, right? Similarly, this remaining term you can draw, right? So here again constant is 1, so simply your this constant multiplier will be there, then there you will require one adder, then there will be a delay element, right? And there will be feedback, coefficient is plus 2 here, so I will take here minus 2. That will be added here, right? This result will be added into this adder. Okay, this is how you will draw the parallel realization, right? So this is for the given equation. Okay, so given equation was this first one, so we had drawn it for this first equation. What we had done initially, for representing these terms in addition form, we have applied partial fraction expansion here. We identified the values of constant ABC, we substituted those values, we have made the powers of z negative, and then we have realized it in this parallel structure. Okay, so this figure indicates what parallel form realization of given discrete time system or given digital filter, right? Similarly, we will try to solve this second example. Okay, so what is the second equation there? So we have this second equation is that h of z is equals to 3z in bracket 5z minus 2. H of z is equals to 3z in bracket 5z minus 2, right? Whole upon 5z minus 2 whole upon z plus 1 by 2 3z minus 1. So z plus 1 by 2 and z plus 1 by 2 and 3z minus 1 is there. Okay, so what is that? Z plus 1 by 2 3z minus 1 is there. Okay, so again, as we have seen in the previous example, we have applied partial fraction expansion here also. We'll adjust these terms, right? Again, from this bracket we have to take these 3 common because we need only z, right? Z term as the first term in each bracket for applying that partial fraction expansion, and then again on both sides you can multiply it with 1 by z, right? Or you can simply send this z on left hand side. Okay, so if you send that z on left hand side, so you will get h of z upon z, and if you are taking these 3 common from the bracket, so 3 will get cancelled, right? Correct. So if you are simply cancelling these 3, so remaining term will be z you have already sent on left hand side, so remaining term 5z minus 2 will be there upon, in first bracket, z plus 1 by 2, and second bracket z minus 1 by 3 is there because 3 were taken common from the second bracket. Okay, so here I can represent a upon z plus 1 by 2 plus b upon z minus 1 by 3, right? So again here I can represent it as, if I'm sending this denominator on the right hand side, so it will be 5z minus 2 is equals to a in bracket z minus 1 by 3 plus b in bracket z plus 1 by 2 will be there. Okay, so if you are sending here, so this z minus 1 by 3 will get cancelled, while when you are multiplying it with this term, so z plus 1 by 2 will get cancelled, correct? So for, so it is 5z. Okay, so for finding value of a, put z is equals to minus 1 by 2 in above equation, right? So if you substitute z is equals to minus 1 by 2, so this term will be 0, right? Here you will get minus 1 by 2 minus 1 by 3, here it will be minus 5 by 2 minus 2 will be there, right? And if you solve that equation, so you will get a value of a is equals to 27 by 5, right? And for b you have to put z is equals to 1 by 3 in above equation, so this term will be 0, so here you will get b in bracket 1 by 3 plus 1 by 2, here 5 by 3 minus 2 will be there, right? So the value of b, after substituting this value of z in this equation, you will get b is equals to minus 2 by 5. Okay, So you'll just try to substitute this value and try to identify the value of a and b, right? So next you can substitute these two values in this equation. That is nothing but the equation of h of z upon z. The value of a is 27 by 5. So 27 by 5 whole upon what is there? Z plus 1 by 2. And here the value is minus 2 by 5 whole upon what is that? Z minus 1 by 3 is there. Again, you can send this z on the right hand side. Okay, you need the negative powers of z, right? So you have this 27 by 5. So z upon z plus 1 by 2 minus 2 by 5 z upon z minus 1 by 3. So if you send this z in denominator, so you will get 27 by 5 1 upon 1 plus 1 by 2 z inverse minus 2 by 5 1 upon 1 minus 1 by 3 z inverse will be there. Okay, now you can directly obtain the what is that parallel form realization from this equation. Okay, so I'll just draw that realization in next slide. So the parallel form realization of given digital filter is shown in following figure. So before drawing that parallel realization, I will just rewrite the transfer function that we have obtained after applying partial expansion in addition function. That is 27 by 5 1 plus 1 by 2 z inverse minus 2 by 5 1 upon 1 minus 1 by 3 z inverse is there, right? So again, as there are two terms, so there will be two parallel lines, okay, in the realization structure. So you can indicate in input it as x of n or capital X of z, right? So the first term, that is constant, is there, so you'll require constant multiplier. You'll multiply 27 by 5 using constant multiplier. Then this structure will be drawn here again by using this feedback in the system, right? So here one adder will be needed. It will take feedback. This will be z inverse. This will be multiplied with the constant. This term is plus 1 by 2, so you will represent minus 1 by 2. This will be added here, right? Then you can indicate it has been added using this adder. Okay, similarly you can have this term, right? So here you are basically applying x of n or x of z. Okay, so from here you can draw the another structure, that is nothing but this minus 2 by 5 constant multiplier is there. Then again adder you will need. Then delay element z inverse, which is multiplied by this 1 by 3 coefficient, and this will be added here, right? So again you can add this into this adder to get the output y of n or capital Y of Z. Okay, so this is how you can obtain the parallel form realization for the given IR systems or digital filters. So this figure indicates parallel form realization. Okay, so till this point we have discussed direct form 1 realization, direct form 2 realization, cascade realization, and in today's session we have seen parallel realization of IR systems, right? So for the given system function, you can represent those terms in addition form, and by representing in addition form, you can draw those terms parallelly in the realization structure by using basic building blocks required for the realization of discrete time systems. So in next session we'll be discussing the another realization structure which is called as transposed form realization, okay, which can be used for realization of IR system. Till this point we have discussed the direct form 1 realization, direct form 2 realization, cascade form realization and parallel form realization. Whatever examples that we have seen for direct form 1, direct form 2 and cascade realization, for those examples you can obtain the parallel form realization. Similarly, for parallel and cascade form realization examples, you can obtain direct form 1, direct form 2 realization and so on, right? So those examples you can try at your own end, right? And if you find any difficulties, then you can ask this. Okay. So in next session we'll be discussing the transpose form realization. Thank you for joining this session.